We know how to graph parabolas that are in vertex form. Vertex form is easy stuff. What is vertex form? It's easy stuff, yeah, but what is it though? What is vertex form? You know what, even before that, what is a quadratic function? You guys know what a quadratic function is?
ax squared plus bx.
Okay, yeah, that you're given the standard form quadratic function, right? But anything with an x squared, y equals x squared, that's a quadratic function, okay? Anything with an x squared. Now, we should know this. We should be comfortable with this. This is a parent graph, y equals x squared. We know that this parabola has a vertex 0, 0. We know that it opens up. We know that the coordinates are 0, 0, 1, 1, 2, 4, 3, 9. We actually get that pattern of 1, 1, 2, 4, 3, 9 from this parent graph parabola, which is a quadratic function. Anything that we call any equation that's quadratic is technically an x squared. It doesn't matter if it looks like this right here, or actually, let's list both ways of looking at quadratics that we've learned so far. We know vertex form. What's vertex form? It's y equals, anybody?
Is that the one? Is that the v or the? Oh,
Well, everybody should know this, I guess not. Plus
Isn't that parabola?
plus k.
That's parabola, right?
Yeah, again, anything with an x squared will give you a parabola. And right here in this form, you have parentheses squared with the x in it. So it is an x squared. It is a quadratic.
How do you call the one with the absolute value?
That's not a parabola. That's an absolute value function.
Okay.
But right now, we're looking at vertex form quadratics, and we also look at standard form quadratics. And what is a standard form quadratics? Y equals
ax squared plus bx plus c.
That's right. Ax squared plus bx plus c, where a, b, and c are just numbers. And of course, we would like nice numbers there. We wouldn't want decimals or fractions. Anyway, these are the two forms that we should know by now. Vertex form is the best because you could see clearly what h and k is, and that's your vertex. Over here, you can't see your vertex, so you have to do some work to find that vertex. That's where we need to know, have memorized the vertex formula. The x value of your vertex will be negative b over 2 times a. And when you use this formula, you should put the b and the a in parentheses, and you just plug in the numbers that you have here and here into there and there, and then you would do the math. And that would give you the x value of your vertex. And if you have the x and you want the y, you'd have to plug in the x value, whatever you get, into these x's and do the math to get your y answer. Okay, we'll get to that in a little while. But before getting to that, let's ask this third question here, this third topic. Do you remember how to find the x and the y-intercepts from Algebra 1? How do you find the x-intercept? Let me move this out of the way. How do you find the x-intercept? That's right. The x-intercept. To find the x-intercept, which is the location of where your graph crosses the x-axis, we must set y equal to 0 and solve. Right? That's how we find the x-intercept. And that's not like some mathematician just randomly created that rule. When we look at any line or any graph that crosses the x-axis, like right here, it crosses the x-axis at -6, that coordinate is -6, 0. And then this coordinate right here crosses at -4. That coordinate's -4, 0. This location, x is 0, y is 0. So all these coordinates that are on the x-axis, all these coordinates that are x-intercept values, all of them have the y value being 0. So that's why in Algebra 1, they teach us to find the x-intercept, you must set y equal to 0 and solve. Okay? Same thing to find the y-intercept. If you're looking at where your lines cross the y-axis, right here it's the location 0, 4. Right here it's the location 0, 2. Right here it's the location 0, 0. Right here the location 0, -4. So for the y-intercept, we must set x equal to 0, right? All of these x values are 0 on y-intercepts. You guys understand that? So that's why in Algebra 1, they gave you the instructions to find the y-intercept, you set x equal to 0 and solve. Okay. Now, why am I bringing this up right now? Because we will have quadratic equations. Y equals, let's say, 3x squared minus 2x plus 5. And I will tell you to find the y-intercept. Okay. So how do you find the y-intercept? Set x equal to 0. So what's your answer?
Y equals 5.
Y-intercept is 5. So on a standard form quadratic trinomial equation where you have the a, the b, and the c, the y-intercept will always be your c value. Yay? But that's not true for vertex form. Like vertex form, you might have y equals 3 parentheses x minus 1 squared plus 4. Your y-intercept will not be 4. That's wrong. Okay, that's wrong. It only works with standard form quadratic trinomial equations. So right here, to find this y-intercept, you would actually have to set x equal to 0 and solve. So you'd actually have to plug in 0 right here. 0 minus 1 is negative 1. Negative 1 squared is positive 1. Positive 1 plus 3, or times 3 is 3. 3 plus 4 is 7. So the y-intercept would be at the location 0, 7. I hope you guys are following along and you guys understand this, because you will have to answer all these types of questions on Friday's quiz. So the goal for this lesson is for you to look at a standard form ax squared plus bx plus c quadratic trinomial equation, and not only just find the vertex, but so these instructions are, we're not practice finding the vertex, we're going to find all kinds of things. I want you to not only find the vertex, but I also want you to state whether it's a maximum or minimum value and what that value is. Also state the axis of symmetry, also state the y-intercept, also state the domain and range. All these different things I want you to state of a parabola that you have not even seen, okay, just by looking at the standard form quadratic trinomial equation. Okay, now whether you're graphing or whether you want to state all kinds of information, the very first thing that you should always do is what? Vertex. That's exactly right. So let's do that. Let's write down a number 1 right here. That's the first thing. Vertex. We know that the vertex is a coordinate, an x value and a y value. And if it were in vertex form, that would just be hk. Think opposite on h, take k for what it is. But it's not in vertex form. It's in standard form. We have ax squared plus bx, which is negative 6x, plus c, which is negative 4. So I don't know the vertex. I need to find the vertex using the vertex formula. X equals negative b over 2 times a. Now, when you use this formula, I highly recommend for you to rewrite it with parentheses instead of the b and the a. Now, once you have those parentheses and you know what b is, put that negative 6 right in there and put the a value of 3 right down there. So let's do that. We have a negative 6 right in there and a 3 down there. Doing the math, a negative 6 is really a plus 6. You guys ever ask yourselves why we do that, where that rule came from? A negative changes to plus plus? It comes from the rule a negative times a negative equals a positive, right? Just to let you know. Anyway, so we do have a positive 6 over 2 times 3 is 6. So x equals what? 1. So we just found out that the x value of the vertex is 1. Now, on any equation, if you know the x value and you want the y value, what do? You just plug it in and do the math. So I'm going to rewrite this entire quadratic equation, but instead of x's, I'm going to put parentheses because I know that 1 is going to go inside of those parentheses. So let me rewrite the whole thing. Y equals 3x squared minus 6x minus 4. And I already know that x equals 1. That's what we found using this formula, x equals 1. So I simply take the 1 and plug it in place of the x's because x equals 1. Now, this is most of the time where students make mistakes. 1 squared is what you must do first, right? You got to use PEMDAS, the correct order of operations. Now, a lot of students say, oh, 3 times 1 is 3, and then squared is 9. Wrong. It's not 9. You got to start with exponents first. Well, technically parentheses, but there's nothing to do inside the parentheses. So we must move on to e exponents. And right here it's 1 squared. That's 1 times 1, that is 1. Bring down the 3, that's really a 3 times 1, that is 3. And then over here we have a 6 times 1, that is 6. But don't forget about the minus sign that was right here. Bring it down. You could have called it negative 6 times 1 will give you a negative 6. Or you could just do 6 times 1 and then bring down the negative sign. Last but not least, bring down that minus 4. And then do this math from left to right. 3 take away 6. That is negative 3. Negative 3 minus 4. That is negative 7. So what did I just find here? The y value, right? It says y equals negative 7. So I just found the y value of my vertex. That y value is negative 7. That's the most important point of a parabola. If you're graphing it, you need that point. If you're stating all kinds of information, you need that point. All other information comes, or mostly all other information comes from that vertex. For example, we already know that the axis of symmetry is simply the equation x equals the x value of the vertex. We already know that the max or min, well actually let's just start working through this. Let's go to the second thing. Do we have a maximum or minimum value? They both start with m, so I'm going to write down the m. Do we have a maximum or minimum value? In order to understand this, we got to understand what this a value tells us, right? What does that a value tell us? Does it open up or down? The a value is 3. Does it open up or down? It opens up, right? So not only does it open up, the 3 causes it to vertically stretch, so it would make the parabola a little bit narrower. Right, so there's a narrow parabola. It's opening up. This is just a visual, just so you could understand whether we have a max or a min value. What's happening on a parabola from left to right? The values are getting smaller and smaller and smaller on the y, lower and lower and lower until they reach a minimum point, and then they go back up, right? So a parabola that opens up, in other words, a parabola that has the a value that's positive, has a minimum value, has a minimum value. Does that make sense? Okay, so this is definitely minimum. It's a minimum value. And where is that minimum? The minimum is at, you could say, the y value being negative 7, because the minimum value is your vertex, and that y value is negative 7. But you don't just, this is a perfectly acceptable answer. The minimum is at the y value of negative 7. Another perfectly acceptable answer is just the minimum is negative 7, because if you're talking about minimum, you're talking about y values. You could even say the minimum is at the location and give the vertex again. That's also a correct answer. Okay? So far we have the vertex, we have the minimum value. What else? And by the way, these are not steps. These are just bits of information that we're stating. And they don't have to be in a particular order. However, I would always start with the first step being the vertex, always. What about axis of symmetry? Once you have the vertex, that's ridiculously easy. Number 3, axis of symmetry is x equals the x value of your vertex, which happens to be 1. That's ridiculously easy once you already have the vertex. So yeah, the vertex is a hard part, because you have to have the formula, you get an answer for x, you plug it in, you do the math, you get your y. That's the hard part. Everything else after that's pretty easy. What else do we have? The y-intercept. Dang, that's the easiest of them all. Because if it's in standard form, we should remember to find the y-intercept, we must set x equal to 0 and solve. So if you know that you have a standard form and you plug in zeros right there, your answer, everything will cancel out except for the c value. So what's the y-intercept? Negative 4. That's your answer. The y-intercept is negative 4. What's another acceptable answer? You could give me the exact location of where it would cross. You could give it to me as a coordinate. Now, what does that mean? Well, if it says x equal to 0, that means that your x value is 0 and your y value is negative 4. So you could say y-intercept is negative 4, or you could actually type it in as a coordinate 0, negative 4. What else? Domain and range. Number 5, the domain is the easiest thing also. Just remember x equals all real numbers. It doesn't matter if your parabola is wide, if it's narrow, if it's opening up or opening down. The domain will always be x equals all real numbers. The range is the one you got to think about. Those are your y values. And it's either going to be above a certain value or below a certain value. That value is the vertex value. And how do you determine if it's opening up or down? With the a. And you already know that the a value is positive, so it's opening up So the range would be at this minimum value and above. What is the vertex y value?
Y is greater than or equal to -7.
Yep. At or above would be greater than or equal to that -7 on the vertex. Okay. So we have stated all kinds of information without even graphing the parabola. And that's the goal for today. Okay. There are a total of 4 of these questions on Google Classroom. I just explained one of them. I'll do one more and then you guys could work on the other 2. Number 3 is one of my favorites because it's so easy to make mistakes. Check it out. Let's begin with the vertex. We know the vertex is a coordinate. I get that coordinate using x equals -b over 2 times a. I know that I'm going to use parentheses to plug in the b and the a. I know that my b value is -10 and my a value is -1. My c value is -4. I don't care about that. Unless we're talking about y-intercept, then that would be the y-intercept, right? As a matter of fact, out of all these things that you're identifying, the easiest is to identify the y-intercept when it's in standard form. It's always going to be that last value. Anyway, back to vertex. The b value is -10. The a value is -1. A -10 changes to a +10. 2 times -1 is -2. So what I have here is x equals -5. So I know that my x value of my vertex is -5. How do I find my y value once I already have my x value? Just plug it in. Plug it into x. So let me rewrite the whole thing. Y equals -x squared minus 10x minus 4. Notice that when I said x, I wrote parentheses because I know what x is. X is -5. That's what I'm going to plug in right there and right there. So -5, -5. Now, what do I do here? I tricked you. You got to think. Now, everybody makes a mistake right here. That's why I like this problem. A lot of people, minus, I got to change these to plus. Wrong. Okay, why wrong? Because order of operations, exponents first and then multiplication. Remember we said the reason why we change a minus to plus, it comes from the rule of multiplying. A negative times a negative is a positive. But we have to deal with the exponents before dealing with multiplication. So what we really have here is a -5 squared, which is a -5 times -5, which is a +25. But the negative sign in front has to come down and be in the front. So it's still a -25. Be very careful with that. And then over here, -10 times -5, that is +50. And over here, -4, just bring it down. And when I work this out, -25 plus 50, if you owe somebody $25, you have 50, you're still going to have 25 left. Bring down the -4. Your final answer is 21. What did we just find here? The y value of our vertex. Our y value is 21. So let's zoom out. Let's go back to the vertex over here. The y value is 21. So -5, 21. That's the hard part. Everything else from there is ridiculously easy. Okay. Let's talk max or min value. Do we have a maximum or minimum value? Max value. And you know what? I might as well do this little demonstration here. Okay. So record me. You? Yeah, record me. Okay. So if I take any object, record up here, yeah? If I throw this up in the air, it travels in the path of a parabola. So you throw it, it's going up, and then it reaches a what? A maximum value, then it comes back down. What kind of parabola is this? It's a -a value parabola because it's opening down. Okay? So if you're wondering, max, min, I don't get it. Well, just think about it. If you throw something up in the air, the parabola will be opening down. That means that your a value is negative, and that's when you reach a maximum height. So that's when you have a max. Now, if you have a parabola that's opening up, that doesn't have a maximum height because this goes up forever, right? So it doesn't reach a maximum. It goes up forever, but it does have a minimum. It comes down, then it reaches a minimum value, then it goes back up. Good? I hope that helps. Alrighty, so we know that because this opens down, it's going to reach a maximum value. So we have max. And what is the maximum value at? Max is at what? 21. At 21. That's right. That's a perfectly good answer right there. Okay. You could have also said, instead of max is at 21, you could have given the actual coordinate of the vertex, -5, 21. Or you could have said the max is at the y value of 21. Sorry.
Can you also say max is 21?
Max is 21. Yes, that's fine. So all those are perfectly fine. All good answers. The maximum value is at 21. The maximum is at y equals 21. The maximum is at the precise location of the vertex, -5, 21. All right, so we have the vertex, we have the max. What is the axis of symmetry?
-5. X equals -5.
Okay, and you don't want to just say -5, you want to say exactly what you said, x equals -5. Thank you very much. That's the only way to produce a vertical line that crosses right through the vertex. Number 4, that's the easiest, the y-intercept. What's the y-intercept? -4. So we know that, you know what, let me zoom out a bit. We know that the y-intercept will be at -4. Or you could give the exact coordinate 0, -4. After all, to find the y-intercept, you must set x equal to 0 and then solve. And if you did plug in the zeros for x, the c value would be your answer. So, I mean, this means something. If you're thinking, it means that your parabola will cross. Your parabola that has the vertex -5, 21, right? Or actually -5, 21 way up here. It's going to cross the y-axis at -4, down here at -4. Anyway, we don't need to draw it. I just wanted to link all that information here on a graph. What else? The domain and range. So the domain on any parabola will be what? That's right. And the range? Y is less than or equal to, because we know it has a max value, and it's all at that max value of 21, at that y value of 21 of the vertex or below. So y is less than or equal to 21. So these are the types of questions you're going to have on the quiz Friday. Now, if you're wondering how the heck are you going to, I can't write this on quizzes. Yeah, you're right. I'm going to give you a quadratic trinomial standard form equation, and I'm going to tell you select all the following true statements. Maybe the first statement says that the vertex is 521. Well, then you wouldn't pick that one, right? But, I mean, what if the next statement says your axis of symmetry is x equals -5? Then you would pick it. But you wouldn't know that unless you know your vertex, right? So
you have to do everything.
Yeah, you pretty much have to do that's what I recommend. Get your equation, write all the facts that you got about it, and then see which one appears on the selections, right? And you would pick all the ones that are true. Sometimes you only get one true statement. Sometimes you might get all 4 or 5 statements true, right? So the only one you don't need to do any math is the y-intercept, like you said. Yeah. Okay. So in Google Classroom, we also have this worksheet right here. This worksheet right here. And I did all of it. You don't have to do all of it, right? But it is practice, right? If you don't practice, you're not going to get good at this. So I would do the first graph, and I would also go through and do at least a couple of these where they want you to state everything that we just stated, right? And remember, what we did state, they were not steps. They were just different facts about the parabola. I always recommend starting with your vertex and then going from there. Let me show you the solutions. So like I said, I did all of this, but you don't have to. I recommend doing the first one because it works out pretty good. The A value is 1. You could use a pattern 1, 1, 2, 4, 3, 9. But these over here, man, I found the vertex. It was -216. I couldn't even put it on the graph unless I counted by 2s. So that came out nasty. I don't recommend doing that one. I mean, you could if you want to. This one was really ugly. Check it out. The vertex was 1/2 and 1/2. Man, like that was, yeah, I don't recommend those. I won't put those on the test. I mean, of course, if you wanted to do them, you could check your answers right there. But these guys right here, numbers 4 through 9, for sure, practice those. And like I said, these are not steps, right? Notice that on the instructions, I did not even ask for the vertex. But you need the vertex to answer anything. So you should always start with the vertex. And then from that vertex, you could talk about your minimum value, being at 5. It's minimum because the A value is positive, which means it opens up, which means it's a minimum value. You could talk about your domain and range because you already know your vertex. See, even though I didn't ask for the vertex, you need the vertex to state everything except for the y-intercept. The y-intercept is simply your C value, right? So with that said, you guys have plenty to practice, and this is pretty much the majority of the quiz on Friday. We are going to learn one more skill tomorrow, and then we'll be ready for the quiz.